Hello, F-sharp, and welcome back. We are continuing our exciting introduction to the features of the F-sharp language. And this week, we get to examine what I find to be a very interesting collection type, and that is the sequence. The sequence in F-sharp is actually an alias for IEnumerable, but F-sharp provides a lot of facilities for being able to define your own sequences, aka IEnumerable, and it allows you to express things that would be pretty mind-bending without it. So I want to take you through how to define some, and then we're just going to explore some of the features around defining sequences. In a future video, I'll go through the functions inside the sequence module so that you know how to do further manipulation. But today is just about creating sequences and defining them. Later, we'll talk about manipulating them. So the easiest way to define a sequence in F-sharp is simply to use a seq and then open curly brace. And then we can put the values we want in the sequence. So 1, 2, 3 as an example. Now you may remember this looks a lot like what you can do with a list or an array in F-sharp. And I'll go ahead and run this code. And I'm going to move this to the right for today because that's going to be good enough for our purposes. So we've defined A is a sequence and has the values 1, 2, 3 in it. You can see the type here, seq. So seq of type int. So I will probably say sequence or seq. It's the same thing in my head. Sometimes I just say seq for the abbreviation to say, because when I look at this, I think seq in my head. But we can also, just like with lists, we don't have to put them on separate lines. We could put it all on a single line. And we can say 1, 2, 3. And just to prove that that works, I'll go ahead and run that. And B is also a seq of type int with the values 1, 2, and 3 inside of it. Now, I'm going to mention something just to plant a seed in your head, but you don't need to worry about it right now. What you're seeing here is an example of a computation expression in the F-sharp language. And this is how we are able to define sequences in F-sharp by using computation expressions. Don't worry what that means. Much later, we will actually dive into computation expressions and how to define them. And I just want this to be kind of a bookmark in your mind so that you can reference back to this as a helpful way of building up your understanding so that when we discuss computation expressions, it makes sense in your head and you have an example of it. Now, okay, we've defined some sequences at this point, but we haven't really, that's not terribly exciting if we can only just define values like this. And again, very similar to lists and arrays, we can use a for loop inside of a seq expression, a sequence expression. For I in 1 to 10 do, and we say, hey, just return I. So what this does is it's going to iterate through the values of 1 through 10, and then for each of those values, it's going to yield a value. So there we go. C is a seq of type int, and just to prove that we actually have something in there, we need to print out the values. So why didn't it print out the values here? So this is something that's very important about sequence and what makes it very interesting and unique. A seq is lazily evaluated. So when you define it, nothing is actually really created. You're not, well, I mean, something is created, the definition of the sequence, but it's not like you actually enumerate the values at that point. This is very different than a list or an array in F-sharp because those are eagerly evaluated. When you define an array or a list using this type of syntax, you are immediately creating an array or a list. It has a place in memory. It exists somewhere. When I did this, though, I am expressing a computation. I am expressing an IEnumerable. Those values haven't been instantiated yet. They don't actually exist. And that's really powerful. And I will show later why it's so incredible. But What that means is that if we actually like want values, we're going to actually have to say, hey, F#, please actually do the thing. And so now when I put in C and I say, hey, run that line using Alt-Enter, the F# interactive is then saying, okay, well, I will enumerate some of the values in that sequence and print them out for you. But it doesn't enumerate all of them. If we wanted to enumerate all of them, we would actually have to loop through all the values. And so I'm going to go ahead and do that right now. So for I in C, do, and I'm going to say, I'm going to use the print function in string interpolation. I know we haven't covered string interpolation yet. I'm really sorry about that. I believe that's going to be the next video. I don't have the syllabus plan in front of me, but we will cover that. Just know this is string interpolation. We're going to talk a lot about it here very soon, but this is a for loop. I'm going to iterate through all the values of C, and then I'm going to print them out to the console. And when I do that, it forces the IEnumerable, the sequence, to actually enumerate all the values. And so it actually processes through them. So that's one of the key things about sequences. They are lazily evaluated. Now that can be really obnoxious sometimes when you're trying to debug and like, I just want the code to run. So sometimes you'll want to like cast it. Well, you want to turn it into an array or turn it into a list so it instantiates all the values for you. But there are design considerations to be had there. I think I'll just leave it at that. So we forced it to enumerate the values and to print each of the values out. Now, of course, again, like in list and array, we can say, hey, I want to for I in 1 to 10 do. And now what we're going to do is we're going to use a nested loop for j in 1, 2, 3 do. And then we're going to return I, comma j. So we're going to return a tuple of I and j. So I can go ahead and define that. We've now defined a computation, like something that can be computed. So if I say, hey, go ahead and run that, what we're going to see is that we are going to get these tuples back of 1, 1, 1, 2, 1, 3, and then 2, 1, and it would go on and on. I really want to see all these values, and I'm going to actually turn down the size of this because I don't want so many values. Yeah, just 2 is enough. And I'm going to, again, use that printing functionality, except I want to now iterate through D. Say, go ahead and run all of this. And so what we get out is I is going to enumerate through the values of 1 through 2. Nested inside of that, j will enumerate through the values of 1 through 3, and then we are creating tuples from that. So 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. Great. What else can we do with that? Well, again, just like list and array, we can use the yield bang syntax to actually concatenate sequences. So let's say E equals seek for I in 1, 2, 3 do, and then I'm going to use yield bang, and I'm going to put a sequence in here of 1, 2, 3. So what this should do is for each I in 1 through 3, we should get another sequence back of the values 1, 2, 3, but this yield bang is going to take that sequence and like compress it into a single sequence. And so I'm going to go ahead and define E, and then I want to print out all those values. So I'm going to say for I in E, print that out. And what do we get? 1, 2, 3, 1, 2, 3, 1, 2, 3. Because what is happening is I is going to take on 3 different values, 1, 2, and 3. And for each of those, it's using this yield bang to take that sequence and kind of flatten the results out into a single sequence. This is exactly what we were able to do with list and with array. Okay. Here's something to think about though. A sequence, like I said at the beginning, is an alias for IEnumerable. So wouldn't it make sense then that we can use this with a list and an array and any other collection that implements IEnumerable? Unfortunately, every collection that I'm aware of in F# implements IEnumerable. So we should be able to do something like this. seek, and then for I in 1 to 3, do, yield, use that yield bang again, but instead of defining a sequence like I did up here, I'm going to use a list. So 1, 2, 3. And because list implements IEnumerable, this should still work, right? Well, let's find out. We are going to go ahead and run that whole thing. I'm changing this to F. So we're actually enumerating the values of F. And when we do that, we get 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is one of the beautiful things about using sequences in F# is that the sequence is an alias for IEnumerable, and IEnumerable works with essentially every collection that implements IEnumerable. So it is a nice way to write code that will work across different types of collections. And just to prove the point, let's do this with an array as well. So instead of saying this is a list, we're going to say this is an array now. So this is how I would define an array using an array comprehension. And I say, hey, I want you to iterate through F2. And when we do this, again, we get the same result. In one case, I'm working with a sequence. In another case, I'm working with a list. And in another case, I'm working with an array. It works with all of them. And that's because seek is an alias for IEnumerable. Okay. Now, one of the mind-bending things about sequences is that they can be used to define an infinite series of values. I mean, an IEnumerable just has a syntax for being able to say like, hey, you know, move to the next value and let me know what the current value is. That's it. It's a very simple interface. And in the future, we will talk about being able to implement that, but we need to cover interfaces in F#. I mean, so that's still a ways down the line, but there's nothing about it which says, hey, the number of values in here is finite. So that allows you to define some really interesting things. So let's do something that seems rather silly. So let G equal, again, we have a seek. Now I'm going to say while true, do 1. What on earth is happening here? Well, we're defining a sequence and we're using a loop construct, the while loop, which we covered yesterday, but its break condition is just true. So this is always going to be true. Like by definition, true is true. So this while loop will never end, so it's always going to be yielding a value of 1. So what happens if we run this? Not a problem. Because what we did is we didn't actually instantiate all the values. Sequences are lazily evaluated. We have just defined a computation, a series of values, but we haven't actually enumerated those. If we wanted to do that, we would need to do this. What would happen if I ran this? Because G is an unending sequence. Well, I can tell you what happens. It would run forever, but I'm not going to run it because, well, let's live dangerously. Let's see what happens. We are printing out ones forever. It will not stop. I have to kill it. So in order to keep this from just enumerating forever, I'm going to use a function that is in the sequence module called seek.take 10. And what seek take does is it says, okay, give me a count. How many values do you want me to take from this sequence? And then you give it the sequence you want to pull values from. So take is a higher order function. No, it's not. I take that back. It is not a higher order function. So erase that. You say how many values you want to take out from the sequence, and then you give the sequence you wanted to extract values from. So if I run this, what it will do is just take the first 10 values from that sequence. So even though we are working with a theoretically infinite series of values. We have no problem with that because it's lazily evaluated. And so that is one of the really incredible things about sequences in F# is being able to express these infinite series. And what's also nice is if you want to say like, hey, I want to generate a repeating series, right? That's very easy to do. While true, do. And now we're going to combine that with the yield bang and say, hey, I want you to return 1, 2, 3. And again, I'm using a list here, but because list implements IEnumerable, it works beautifully with sequence. I'm going to go ahead and copy and paste this down and say, hey, I want you to take from H now. And what this will do is we now have a sequence H, which just repeats the same values over and over and over again. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So we can continue to pull values from H and we're still going to get this repeating sequence. This is incredibly valuable when you want to express some series of values that you just want to pull from for like the purpose of a simulation or some type of model, but you don't want to instantiate all those values because it's in theory a huge number of values. Like, hey, I need to pull 1 billion values, but I don't want to instantiate them all at the same time. So that is why sequences are very powerful. They give you this really simple, elegant way of expressing these infinite series of values. So they are a fantastic tool, and there's a ton more that we can do with them, but I wanted to keep this very focused on just kind of defining simple sequences off the bat. Later, what we're going to do is we're going to go through the functions inside the modules for lists, arrays, and sequences and look at how we can manipulate them and work with them. So that's all I have for today. Let me know, what are some crazy ideas that you have for generating some possible infinite series using sequences, or what have been some challenges that you've had in the past where like, oh, I needed to define a series of values, but I couldn't put them all in memory. What have your approaches been? How do you think we would do that with sequences? So that's all I have for you today. Thank you very much for spending some time with me. I really appreciate it. Thank you very much. Bye-bye.